So you see it very clearly. Well, then I'm going to use another 15 minutes to quickly walk through the MATLAB command. The command is called f-min-com. What that means is f minimization under constraint. Basically, that is the keyword. And to get the detail, you cannot possibly remember everything in this 15 minutes, by the way. You can say help f-m-n-com. You're going to find the help menu, explain all these parameters. Now, our example is to minimize this strange, the same function, actually it's the same objective function, but under two inequation constraints. So those are the two constraints. To use the command, this is good, less or equal, that's not good. You cannot be bigger or equal. Do you remember the simplex method? You cannot make this bigger or equal either. You need to always write into less than this. But that's no big deal. You just need to move x1 minus x2 minus 10 less than 0, same thing. So first one, you write into canonical form. Everything should be like that, negative. Then you write these two constraints as less or equal. This is the form C. That's the step one. After you finish this, you need to write your own M file. That's not hard. The first file, the M file is objective fun. The file name and the function name must be the same. That's the requirement of MATLAB, if you remember. Well, then this function return the f, b, this function. You just need to follow the Maple or MATLAB convention. That's kind of like a Maple convention. x1 is a variable, x2 are the variable. That's the preparation step one. Step two, you need to write this constraint function. Conform is the constraint function. The name could be different, but you need to match this file name and the function name. And this function return two vectors. The vector C is the constraint equations. And no, this C is a constraint in equations. The C equal, the next is a constraint equations. In that case, you don't have anything. You just put a bracket, means you don't have. Because our example have no equation. If you go back to the second example, you have two equations here. You just put the two equations in the CEQ. The CEQ is a 2 by 1 column. The first column is this. That's the second column is this function. Now you check. It match to, see, oh, you need this one. You need this one. That's the first row, that's the second row. Okay, you write your constraint function. Now, that's step 2. Let's go to the step 3. Step 3, you're going to search your solution space. I call it a feasible domain. In this domain, that's the tricky part. You need to have a start point. The start point is the tricky part. Sometimes does not work. You get to try, but most of the time okay. Just give your initial guess around the solution. Well, how do you give a reasonable one? Like here, how about you just start from here? 0, 0. That's very reasonable. Doesn't matter. They're going to search this way. Remember the simplex method? They always go through the edge to go to the lower place. That's how they search. So as long as you give a reasonable start point, it will work. Now come to the big function. This function take 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, could be 11 of matrix input parameters. And they all have their meaning. You don't have to memorize. And then return the x. That's the design variable. And the f, that's the objective solution. That's the solution. So in the option, they have a flag tell you right or wrong. Usually 0 and the positive is right. Negative is wrong. So the return is x equal this and this. And the solution is 0.0236. Now it's complicated. Once you get the solution, you still maybe say, hey, let me check. I'm going to explain all those in a minute later. So in this particular problem, all you need to remember is write your own objective function and the constraint in equation and the equation here. You only learn the 2 parameters here. And then you need to add another start point, whatever you pick. So you get the solution. So how do I check? I will check the C, which is the constraint in equation. You remember, need to be less or equal than 0. So what you get? That's 10 to the negative 7 power times negative 0.032. That's almost 0. Even you time this positive, that's still 0 in the small tolerance. That means good. But in the case you don't have that, give you this, or just give an example, that's wrong, because you need to be negative. Because your constraint is all negative, less than or equal than 0. So this is even a little bit bigger than 0, fine. 0 to the 10 to the negative 7 is smaller than a millionth. Good. Okay, that's the easiest example. Now let's look at another parameter with the boundary constraint. You remember the first example? Bigger than 0, less than 3 for the x1. Oh, that's the second example. x2. So in here, you got another 2 vector here. The lower boundary is 0, 0. The upper boundary is 3, 3. That's your option. You can put it there as your constraint. Another issue is sometimes you get a halfway boundary like this. You only get 0, 0, and then you have a low boundary, but you don't have an upper boundary. What do you do? Worst of all, you can have this. x1 is between 0 to 3. x2, you don't know. Maybe just say bigger than 0. And then you can still put this parameter here, but how about the upper limit here? You cannot just put 3. That's not good, because you have 2 variables. And the tricky is you put the infinity here. That means less than infinity. Of course, that's good. So that's a little tricky part. So if you don't have it, you put the infinity. Another example, if like this, what you do. And then your lower limit will be this, negative infinity and 1. Your upper limit will be 2, positive infinity. That's how you write your low boundary and up boundary. Well, then what are those two examples? Where you put those? You put into the last parameter. You can read this. Let me see the time. Okay, I have about 6 minutes. So you put this upper limit and the lower limit into the last, this is the 6, 7, 8, 9, no. 1, 2, 3, 4, 5, 6, 7, and 8 position. You have to be, and that's 9 and 10. So what are those? Those are the linear constraint and the linear inequation constraint. Those 4 are the, I think I talked a little bit in the linear regression method. And the linear inequation go first. You have the A less than B, no, less than B. A in equal less than B. Then you put the matrix A here, B here. And the linear equation is A equals B equal. And then you put this 2 equation here. I think we talked a little bit before. That's a very powerful tool, by the way. And all you need is to fill the right parameter into the right location. If you choose such a project, we are going to talk more and help you.